Cancel school.
So we're going to talk about polynomials. Shh. Tell me what a polynomial is.
A bunch of
We talked about this initially.
like a binomial too.
A binomial to what? There's a word
Expressions?
for it. You're close.
Equations?
Terms. You're exactly right. Terms. So, all right, let's see. We said a binomial is two terms. What's a term?
Like x plus something.
Or 2x. Right?
So it could have a variable. It could have a constant. It could have a leading coefficient. It could have an exponent. That's all terms. We're just
monomial.
multiplying. We're not. A monomial is one.
Monomial.
No, it's just monomial. Yes. An example of a binomial might be x squared plus 3, or a monomial might be 2x, and that's it. What's another type of nomial? Before trinomial.
Then that would be considered a polynomial, though.
So my question is, this is 3 terms. What is a polynomial?
Anything above 2.
Anything above 1.
Or no, anything above 1.
Right. No.
These are all
Not
polynomials.
monomial. A monomial is not.
It's polynomial means one or more terms.
No, poly means many.
But by definition, it's a polynomial if it has one or more terms.
That.
So we talked about trinomials extensively with quadratics. A quadratic or a trinomial is a polynomial, but every polynomial is not a trinomial. Does that make sense to you? It's kind of like the square and rectangle thing.
Wait.
Every trinomial is a polynomial, but every polynomial is not a
Oh
trinomial.
yeah, because it could be any
So
of
this
those.
1 is a polynomial?
Yeah. Yep. All right, so here's what it has to have. I feel like we did this. So if we did, stop me.
Well, like we did this like in like other grade.
Okay, so by definition, a polynomial, besides its terms, must have positive whole exponents on x. Did we do this?
I know that.
And all coefficients must be real.
Yeah, we've done this.
I feel like we have.
Definitely did not. I don't remember this.
Okay, well, we just did it again. If we did.
Coefficients.
All right, let's talk about some parts of polynomials. Polynomials. First thing is we want to stay in standard form.
Yeah, Miss McGee. We wrote down everything we just wrote down, and then all the properties, and that's about it.
Okay. Standard form. Standard form of a polynomial puts it in order of its exponents. So from the biggest exponent, and y'all are used to doing this, to smallest.
Standard form.
Standard, yeah, that's just an abbreviation.
Like AX plus GX plus or C.
Well, it's just whatever you have with a trinomial, it looks like this. Right? But that's a trinomial, so it's not necessarily encompassing of all polynomials, but then maybe the point is B, C, you don't have to write this down. D, I'm gonna put dot, dot, dot. Because it keeps going. The point is that you put it in order of the biggest exponent down. And the reason we do that is because it helps us to look at some things, okay? And some parts of that polynomial. This biggest exponent is very, very, very important to our polynomial. Does anybody know what it's called?
Your leading exponent.
Nice
Leading
try.
coefficient.
It's not a coefficient, it's an exponent.
In front.
Are we just guessing? We don't know.
Let's put
Nobody
it in
knows.
front.
Okay.
Well, I know the number's the leading coefficient, so that's why I said leading coefficient.
It's a degree.
The degree is the biggest exponent.
We have a bunch of degrees, so if you look down there, plus if you went to South Carolina.
What?
He was making a joke.
Remember that one? That you have
I wish it
degrees
was
down
funny.
there.
I'd have liked to have laughed
You
just
have
now.
degrees down
Okay.
there.
No, it has one degree. The biggest exponent. You can't have more than one biggest. There's only one biggest. Each polynomial has its own degree. Okay. The biggest exponent, and notice I said hook to the x there because I'm not looking. I could have 4 squared x. That's squared, that 2 is not my degree. That's just hooked to the coefficient there. So don't let that throw you. So hook to the variable. All right, that's my degree. Now, y'all have already said this, so I'm sure you know. What is this called? Leading coefficient. It leads the polynomial as long as we are in standard form.
Yeah,
Run out of room here.
yeah.
Una mas. You know what that means?
One more.
What's that one called?
My Spanish teacher.
That's called your backup coefficient.
No, that's not a backup coefficient. What is this
The
called?
lag coefficient.
Oh, dear
The
Lord.
lacking.
The y-intercept.
Lackland.
It is a y-intercept.
The C.
Give me another one. Oh, my gosh.
Oh,
The,
we call that. You know, it could be B actually, because in that's supposed to be, that's the y-intercept.
Y'all.
So C equals B, so if C equals B, then they
Why
equal
don't you
each
just
other.
tell us? Because no. The constant.
Oh,
It is
that-
not the consistent. It is the constant. The constant does not have a variable in it, hence why it's called a constant. It has a constant value that never changes. It does not vary because it does not have a variable hooked to it. Okay, so it is constant. Does that make sense to everyone?
Yeah.
Junior going in black has walked in the room.
All right, let me give you an example. Let's do this one together and see.
Let's do it by ourselves.
Let's do one together first.
Oh, God, you did a fraction.
Okay, that's the leading coefficient. That's the degree.
All right, stop.
labeling.
8x.
Oh, no.
First.
My first question, and I probably should have put this on there, but my first question is this a polynomial?
No, it has to be
Why?
a whole number.
No, because there's two variables.
You're not
There's
smart.
2 variables in there. I'm throwing an extra variable in there, okay? So no, this is not a polynomial, so I can't do anything else with it right now as far as looking at the parts. But let's look at this one.
Wait, why?
Because this second variable, you can only have x in there. You can only have one
Or you
variable.
can only have y.
Well, what about, wait, never mind.
You know, AX plus B, that's plus C, X has a bunch of different letters.
X. A and B are like numbers.
Look at this one. We'll get to some where we can, but for right now, let's assume no, because
It's 1122.
Pi x.
Well, yeah, that would be because pi is just a number. And if you ask Randy, he can recite it for you.
polynomial, yes or no?
Yes.
Yeah,
But there's a pi in there.
but it's a number. It's a number.
It's a number and it's a coefficient. But there's a square root of 2 in there.
That's a number too.
It's still a number, it doesn't matter, right?
But that would
What
actually, wouldn't that be the
is-
leading coefficient?
Yes,
Yeah.
that's what I was gonna say. What is the degree of this polynomial?
5.
5, that's the biggest exponent. So the leading coefficient's always hooked to the degree term, so what is the leading coefficient?
Negative 1 square root of 2.
Negative square root of 2.
Negative 1. It's negative 1 technically.
No, it's not.
Okay, it's just negative square root of 2.
Opposite square root
Ah,
of 2.
okay. Okay, let's move on from this. Yes, it is.
Yeah,
It is, it
Technically
is.
negative 1.
So your
outside
constant would be
square
2, and what's B considered?
You don't necessarily have, what do you mean? If you put it in order, it would be negative square root of, you gotta get away from thinking A, B, and C a little bit whenever we get to here. I
No,
put
I'm just
that.
saying like, cause A is your constant and C is your, I'm sorry, A is your leading coefficient. C is
So what would the constant be? Is that what you're asking?
No, I'm
What's
saying
the
like, what would
constant?
B be
No.
considered? Because A
Nothing,
is
there's no
your leading
constant.
coefficient, C is your constant.
When you have a trinomial that is a quadratic, this is a trinomial that is not a
So
quadratic.
there's no constant.
So what would your constant be?
What's a
0.
constant?
0. Constant is the term that does not have a variable hooked to it.
0. Let's go.
I'm also missing, and this is important for you to see because when we get to division on Monday, you will need to recognize this. I'm missing several terms. Oh, that's a 5. So this would be a 4, but it's 0, right? There's no 4th term there. There's also no 2nd term there. So these are what we call placeholders. We hold the place of anything that's
Do we
missing,
have to
okay?
do that on the
You don't have to do that today. You'll have to do this when we get to synthetic and long division for sure.
Okay, hold on, wait.
Today, we're doing addition, subtraction, and multiplication though. Okay. Just, it was a good place to kind of throw it in there.
So E is the prime.
No, negative square root of 2 is the leading coefficient. Because it's the coefficient hooked to the degree term,
What's the then?
whatever's
Can
in
we just
front.
simplify the zero then?
Yeah, but I'm just saying, whenever we divide, you have to have a place for every, starting with the degree down to the constant. All right. Yes, yeah. All right, let's add and subtract. This is really, really easy, but you'll want to write this down somewhere because for some reason, whenever we start doing all the operations, students start to get things mixed up. This is going to be all about combining like terms. That is all this is. So before I go any further and show you that, let's talk about what like terms are and how we combine them. This is what you need to have in your notes so you can go back and look. First of all, what are like
The
terms?
same, like, they have the same thing.
Same what things?
Variables.
Okay, it has to have the,
Exponent.
which exponent?
Like, if it's like x squared, you can only add another x squared.
Okay, so same variable and same exponent on that variable.
Yes.
So, for instance, give me an example of like
5x
terms.
squared, 3x squared.
5x squared, come on,
Here's one.
and 3x squared are like terms because of the x squareds that are hooked to them. Are we all in agreement?
And you can add the numbers.
Can everyone in here identify like terms?
Yeah.
Okay,
It'd be
so-
8x squared.
To combine them, and this is where things will start getting confused in your head as we do other operations. When you combine them, what is it exactly that you combine?
The numbers, not the variables.
What numbers? The coefficients. That's exactly right, Fatima. To combine them, I combine the coefficients leave that exponent alone. It doesn't change, right? It stays x squared is what I'm trying to get
Well,
to.
it could change.
It's going to change when we multiply, but it's not going to change when we add or subtract. So in other words, 5x squared and 3x squared, I'm only combining the coefficients. So it would give me 8x squared. Does that make sense?
Yes.
Do we all remember doing that?
Yeah, can we do a little quick because it seems not close to time. It's 11.
No, it's not.
It's 11:27.
All right, let me show you an example. I think I'll show you a subtraction first. I feel like we have done this, where we did same,
I didn't
change
see this
everything.
online.
Maybe I'm thinking pre-cal when we
I didn't see
recap. Okay. Okay.
Yeah, but it like wasn't like the same thing though.
Did we add and subtract quadratics?
No.
Okay.
Hey, yo, you in the back there. That's the number.
All right, let's say I have 4x squared minus 5x plus 6. Whoa, Nelly.
You can't do anything with that.
Minus,
Here we go.
But we did it with the imaginary.
okay, maybe that's what I'm thinking.
No, not like that.
Wait, did I say divided?
That's a plus. My pen's lagging a little bit. All right, so I want you to look at this for just a minute, and I want you to think about something. And y'all are right, we did talk about this a little bit whenever we did complex numbers. Because everything in this second parentheses is being subtracted, you can think about it like there being a -1 in front, right? It distributes through to everything. So it changes all those signs.
Yeah. Since there's not another exponent for the 3, for 3x to the third, would we just leave it negative?
So, yeah, so what, absolutely. So what I would advise is looking through all of them, finding the biggest exponent, because some of them may not be in standard form when you have them, okay? So looking, and y'all noticed right away, look, there's that 3x cubed there in the beginning, and there's not another cube. And I'm going to go ahead and do this. Instead of having the -1, I'm going to distribute that -1 through. So I want to keep it in standard form, and this is the only power of 3 that I have. So I'm going to go ahead and say, okay, negative 3x to the third. When I'm done with that, I'm in the habit of marking them out because otherwise they start to get confusing on what you've used and what you haven't. But you don't have to. So now that's a power of 3. Do I have any powers of 2?
Yes.
4x squared and positive 2x squared would give me positive 6x squared. Remember, add the coefficients and keep that variable the same, that exponent the same. All right, so I'm done with the powers of 2. Powers of 1,
Yes.
negative 5x and negative 3x would be negative 8x.
How did I get negative 2?
Because you added.
3.
No, because negative 5x minus negative 3x.
Minus 3x.
If you keep the minus in the middle, then it would be negative 5x minus a positive 3x. If you change all the signs in here, you have to change this middle sign to a plus.
I wrote it wrong in the beginning.
And then constants, I have a 6 and a 1, which leaves me a for adding and subtracting. Okay, but we're going to multiply 2. But quickly, looking at this, what is the leading coefficient?
Negative 3.
Degree.
3.
Constant.
7.
Is it a polynomial?
Yes.
If you multiply polynomials or
It's
you
a
add or subtract,
quaternary.
you always get, it's a cubic.
I thought it was important.
That was a plus sign in the beginning, you changed it.
No. Everybody hear that? Because I wasn't going to do an addition example unless you need it.
No, we don't.
If it was addition to
Well,
start
we-
with, you change nothing.
we might.
Okay? All right, let's do multiplication. This is when it gets fun.
Yay.
No.
What do you say it's smart?
See?
Now you got a question.
Let's start easy and then we'll do a little bit harder. Now, when you multiply terms, before I start, okay, this is different than combining like terms. This is multiplying terms. When you multiply terms, what do you do?
Well, you add the exponents.
Okay, so somebody said add the exponents. That's right. What else do you do?
You actually multiply.
You
the
actually multiply the coefficient.
multiply the numbers together.
Multiply coefficients. So just an easy, just to show you how we do this, let's say I have, come on, 2x squared times,
Times 3x to the 4th.
ooh,
So that's a root.
Plus
79, 7.
x to the 3,000.
Oh, I didn't know we were doing a whole
Plus, minus
there's another one?
22
How many more?
x to the 7th power.
Minus 76x to the 27th power.
okay, that's enough. All right, so if I multiply this out, this is a distribute problem, right?
That's
Do you
right
see
here,
why?
something else.
This is an easy one.
All right, so multiply coefficients. Good thing I got a 2 out front, so all you can do is
Yeah.
double everything because y'all went like all out.
7 out front?
You could. Negative 6x, the exponent becomes 6. Okay? I know this seems very basic whenever I'm telling you multiply coefficients, add exponents, but as you start doing this, you start wanting to multiply exponents, or you start wanting to leave the exponents alone. And it'll start getting jumbled up, trust me, it always does. All right. Plus 10x to the what? Yes. Minus
Wait.
44x to the minus 152
Yes.
x to the,
29.
is it a polynomial?
Yes.
Yes.
What's the degree?
29.
Leading coefficient? Constant.
0.
Let's kick it up a notch.
That's
That
a lot to
was-
go.
that was
You gotta-
some
you gotta
good
write the
stuff.
zeros. You gotta write 0 to 28, 0 to 27.
No, I'm not. That's only whenever I divide. I have to do that.
What about, so like, if it asks like, what if we would have written a constant in there, but you can't multiply a constant by x?
You can.
How? How does?
3x times 12. Stop it, Luke Clyburn.
You can do that?
Yes, you can.
Oh, okay.
Because really, this is like x to the 0, so you'd multiply the coefficients and you'd add the exponents, yeah. All right, let's do a good multiply and I'll be done.
And then, oh my god, it's almost time to go. It's 11:35. Hurry.
This multiple.
Okay, at 8 seconds. I have to be at 8 seconds in about 20 minutes. It takes me a good 30 to get there.
Yes, multiplication still.
Yes, look at multiplication.
I do have one more little thing to show you after this. It's not really much, just to show you examples.
You should throw in some other questions in the last.
Actually, I lie. I'm going to do one more example. All right, so this is distribute, right? Okay. Think foil on crack. Okay. This is why. Steroids don't. All right, so.
Foil on that good heroin, that good kush.
Oh my gosh, you took it to a whole other level.
That good kush, that really good stuff.
It's recording, Dylan.
I hate caffeine facts.
Senior Wooly did find it.
There we go. All right, every term in the first parentheses has to multiply to every term in the second parentheses.
Right.
So start with the first
So
one.
2x to the 6th.
All right, 2x to the 6th.
Minus 6x.
No, minus, it'd be plus 2x to the 2nd.
All right, hold on. Let me make
You
sure
have
I
to
heard
leave
you. Hold
that.
on.
Oh, because it's like 6x is the 1, right? Yeah, so yeah. And then
Yeah, this is 6x to the first.
Yeah.
So it's 3 and 1, which is 4.
plus 7x to the
Oh, shoot, I'm not right. You could boil the whole thing.
Okay, now stop.
plus.
That's the first term to everything in the second parentheses. Now,
Anybody ask? No,
y'all be nice.
no one else.
Now we take the second term to everything in the parentheses.
Literally.
So you see why I said this is on crack, because this is lots of multiplying,
Then we
right?
just combine like term.
All right, yes. All right, y'all stay with me. Y'all are chit-chatty today. 2x squared plus 2x cubed is...
4x to the 17th.
Dylan.
I'm sorry.
I wrote 50.
See, I told you,
It's
you
to
will
the
start
fifth.
getting it mixed up. It's because you're shouting out these random numbers and y'all are just, I can't even concentrate.
Okay, the next
Okay.
one's going to be negative 12 to the 3rd. I got the right one.
Thank you.
Negative 12x.
It's something like that.
Then the next one that
Is
was gonna be
plus
14x
to the second.
the 3rd.
And so now I'm done with that middle term, right? This is not really anything hard conceptually. It is just tedious. All right, now negative 5x. I'm going to do this one a different color. Negative 5x times 2x cubed is negative 10x to the 4th. Dylan, you're being not so nice. Negative 5x times negative 6x is positive.
30x to the 2nd.
Thank you. And then negative 5x times 7 is negative 35x.
Negative 35x.
Like terms.
Well, there's a bunch of them.
I choose the final.
2x to the 6th. Now, any powers of 5?
Yes.
Yes.
Minus 16.
How about powers of 4? I have negative 6, negative 10. Is that it?
Yeah.
So negative 16 x to the 4th. Powers of 3,
There's
7
about
and negative 12.
Landon, you write all this down?
It'd be
So negative 5.
there might be some of them. Negative 5x to the 30.
Powers of 2, 14 and 30.
Well, that right there, that will be 46. I mean 44.
X to the second.
All right.
And then it'd be minus.
I think the problem is probably in the tedious work of it, not
It's
in the
not hard.
concept. Am I right?
Yeah,
It's not
Okay.
hard at all.
Is it a polynomial?
Yes. I don't know.
Here's here's a heads up.
Nothing.
If you add, subtract, or multiply polynomials, you get a polynomial back out.
Exactly.
Notice I didn't say
1,
divide,
2,
you don't
3,
always
4,
do divide.
5, 6.
All right.
This is 6.
What is the degree?
A 6.
What is the leading
2,
coefficient? What is the
0.
constant? Thank
So
you.
negative 35.
All right, let me show you this one other little thing, and I'll be done.
Negative
Oh,
35x.
shoot, you're right.
Wait, Miss Lee, how would you not always get polynomials back out?
When you divide, because you think if you divide by an x,
You can get nothing.
if I have 3 over x, that's the same thing as 3x to the negative 1. And you can't have a negative exponent and it be a
How
polynomial.
do that be the same thing as 3 over 2 negative 1?
Because remember your properties of exponents?
Could you teach me that again?
Any negative exponent moves to the bottom and becomes positive, and then vice versa. If it's negative in the bottom, it moves to the top.
Can you
and
throw some of
becomes-
those questions in our homework?
Please.
I wish the
All right.
Because I forgot.
Look back in
All right, so listen. Let me show you this one other little thing.
Do I have permission to fill this water bottle with something?
No. How might I simplify that?
By
you would
Or
distributing
expand it.
Distributing the exponent.
To everything.
Oh, don't you say that.
What did he say?
He said distribute the exponent.
That's what we did last time.
Why
wait,
can't I? What did I tell you? What did I tell you to write on the bottom of that? It only works when you are multiplying or dividing. That's it. If you are adding and subtracting, it tells you how many times to write the whatever you have here, the binomial.
How much did they do that?
So you write it 3 times.
So you write it 3 times. Now,
What is that advantage?
That would be the same thing.
do not, and listen to me carefully, do not, come here, do not do this. And say, I'm going to distribute this here, 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 and here. It doesn't work that way, okay?
Well, wouldn't that just be the same thing?
I'm telling you. Here's what you have to do. When you multiply more than 2 polynomials together, you have to take them 2 at a time.
We could just leave it like that.
Simplify and then multiply. Not if it says, and then multiply to the
2
next.
At a time.
Yes. So here I would distribute this through.
I'm literally so hungry.
Okay, shh. Pay attention. 2x times 2x is 4x to the second. 2x times 4,
That would be
8x. 4 times 2x, and 4 times 4.
16.
Clean this up.
Clean it up.
4x squared
so they could just go
plus
ahead and cancel.
16x plus 16. Now take it to the third one. If there was a fourth one, I would need to do this and then take it to the fourth. Okay?
Wait, why? Never mind. Never.
You could do 2 at a time if you multiply the 2 products
Yes, you
together.
could if you had 4.
Alright, it's gonna be 8x to the third.
It's gonna take a while. You got it.
8x to the third
Oh, that was right.
plus,
Plus 32x. This thing.
Dylan, you're being a jerk right
No,
now.
no, 16 times 2 is 32.
4 times 4.
Oh, I skipped.
No, I'm done with
I
that.
skipped.
I thought you were
I'm so
trying to
serious.
throw me again.
He was.
He got lucky. He got lucky.
16x times 2x.
That's 32.
Now, there you go. That's your 32x squared. How about 16x times 4?
That's a lot.
I forgot what that.
Double
90
32 would be
64.
64.
Yeah.
Don't call people stupid. That's not nice. 16 times 2x. Obviously, it's not the girls.
I'm sorry.
It's 32x plus 64 like terms, 8x cubed. 16 and 32 would give me 48. 64 and 32 would give me 96. 64, is it a polynomial?
Yes, always.
What's the degree?
3,
Leading coefficient?
8,
God,
0,
64.
54.
I love math.
I love it.